it brings us to the final section of Variety Hour, which is our long talk. So I'm going to hand it over to Pen, who's going to sort of, as I alluded to, give us an orientation on all things open source technology for conservation. Take it away, Pen.
Right. Thank you, Alex. Thank you so much for having me here today. It's great to see all of you. I'm very lucky to be working with Shannon and Bree as part of the WILDLABS Open Source Solutions group. So I've done some ecology and conservation research in the past, but my projects over the past few years have been about how to do open science and incorporating open source technologies into science, including conservation science. And when I talk about this, I always start with the way I think about the difference between doing science versus alchemy. And this comes from a quote I really like from a very famous science fiction author called Cory Doctorow, who said that if you look at what alchemists used to do, superficially, they were running experiments, they were taking notes, and they were learning from the experiments that they did. But they kept what they knew a secret from each other for hundreds of years. And because of that, they didn't advance the state of the art very much. And every single alchemist had to learn in the hardest possible way that drinking mercury is a bad idea. And I think this really says a lot about the core of what sets science apart from doing alchemy. Because when we do science, including conservation science, we're building what we do on knowledge that came before us, and we have a responsibility to the scientific process to continue to share what we're learning with people that come after us. And it is very much the spirit that brought me to open source technologies. So if you look into open source software and hardware, there are formal industry standard definitions for software that's developed by the Open Source Initiative, and also for open source hardware, which is maintained by the Open Source Hardware Association. Now, those definitions are pretty long, but they basically boil down to the fact that all open source technologies have to come with four fundamental freedoms for the users of that technology to use it, study how it works, modify and remix it, and continue to share the underlying source code or designs with other people without any restrictions, right? And Alex was alluding to some cool projects on the WILDLABS inventory. And one piece of software I always like to talk about that I think is a fun example is the Q Greenland project. So this started as a collaboration between different scientists, whether it's people working in conservation or geology or climatology, with the commonality being that their work happens in Greenland. And they want to develop a common geospatial data platform. So they started with the open source QGIS software for geographic information systems. And they put in geospatial data about Greenland and a lot of the tools for analyzing that data all into one package built on top of QGIS. Now, back in 2023, they wanted to run a workshop to teach people how to use this entire package. But they discovered that it was really hard, right? Because in a room with 20 students, they had to set up QGIS and QGreenland on 20 different computers with different configurations. And that was very time consuming. So they went to Jupyter instead. So Jupyter is a computational notebook, usually used for writing code in Python for doing data analysis. But they built on top of that, so it actually runs a complete Linux desktop environment, which is an open source operating system in which they installed QGIS and then they put the QGreenland geospatial platform on top of all of that. And they wrapped all of this into one package that you can open in a web browser so that all of the students in the workshop, they get the same experience to learn how to use QGreenland. And this was only possible because all of the underlying components are completely open source with those freedoms that I told you about, so that they can freely remix those components into this particular package to use in their geospatial workshops. So I think this is a really cool software example. And some of the work I've been doing have been on the hardware side of things. And if you really think about it, hardware forms the physical layer of science. And we rely on that to do so much of the work, that we do. In fact, it was physical hardware that took people to the moon. And when we go out into the field, we also bring a lot of hardware with us. There are a lot of interesting projects here. There's OpenCDD, which I really love, which was started uh, by a friend of mine for measuring conductivity, temperature, and depth in a lot of marine applications. I work with Bree, and Bree works with a whole team on the Mothbox project, which a lot of you might have seen on Well Labs, which is a mobile insect monitoring platform that's completely open source. But the example I want to go into a little more today is the Open Fluxure Microscope project. So this project was started in the UK. I know some of the founders of this project. They're amazing people. And for those of you who have used microscopes before, you'll know that it's dominated by a handful of manufacturers in the world, like Leica or Nikon. And they sell very expensive microscopes, but microscopes are so important to so much scientific work, right? And what sets Open Fluxure apart is that it is completely open source, where if you go to their website, they give you the complete schematics and design files for building the open fluxure microscope, plus complete building instructions that kind of look like, those IKEA furniture assembly manuals, if you've seen those things. But it teaches you how to build this microscope on your own. And it is a research grade microscope. So it does the traditional things such as bright field imaging, in this case, looking at stained blood smears, or fluorescence imaging, right, which is another common application. But because it is completely open source, there's actually a different research group on the opposite side of the world who took the open fluxure design and improved it to increase its resolution for fluorescence imaging to achieve things that weren't possible before. And I think that's also really cool. But what's also really important about open source technologies is that because of that reduction in the cost for locking down your designs, it actually makes it a lot cheaper for other people to build. So if you go out and gather the material you need to build the open fluxure microscope, putting all of it together, the total cost is starts at just $200. So if you've bought a lab grade microscope before, you'll know that this is sometimes an order of magnitude cheaper than the microscopes you usually buy for the same performance, which I think is just absolutely mind blowing. Now, this actually led to some environmental applications. There's the Endoscope project, which learned from the open fluxure design to develop a visualization system for analyzing marine plastic pollution. And I think that's another cool example of remixing that happens in open source technologies. But I want to touch on why I think open source tech is particularly important for conservation work. So just recently, I was at the London Natural History Museum, and at the end of one of their exhibits, they had the sign up, and within the sign, they were acknowledging that their collections were collected within the context of empire, colonialism, and exploration. And this is very much true for ecology and conservation research as well, where we have to confront the imperial history of ecology and conservation science. I hope and think this is something we can all agree on. And my message here today is that technology plays a very important role in this imperial legacy. There's a lot of talk about the problems with closed source technologies. First of all, if we do science with it, it's fundamentally not reproducible. There's a lot of vendor lock-in, forced obsolescence that creates a lot of e-waste, for example. And because of this monopolizing practices, it leads to very high costs. And all of this put together makes the fact that closed source technology reinforces a lot of global inequities. I personally know conservation scientists in the global majority who are in the countries that they live in. They might need a particular piece of equipment for the conservation work they want to do, but the vendor and manufacturer doesn't even sell it in their countries. And if they can somehow get access to it, they cannot afford it. And if they can somehow scrunch together the money to buy it, once they finally get it, they're not even allowed to maintain or adapt that piece of equipment for their local needs. And it just becomes prohibitively difficult for researchers all across the world to have access and be able to build on the technology to do the conservation in the right places. So I think when it comes to the social impact of technologies, it's really important to be mindful of a lot of the global inequalities that come with them. Because technology is not neutral. Technology is a projection of power, and closed-source technologies come with the risk of perpetuating the systems of oppression that still exist in so much of the science that goes on today. So I think we have a responsibility to make use of open source technologies. And going back to the open fluctuator example, this they were able to adapt it for malaria diagnosis. And there are researchers in sub-Saharan African countries who are able to locally produce and maintain open fluctuator microscopes and gain access to them in ways that they weren't able to before. And because OpenFletcher is open source, another cool thing is that it actually creates commercial opportunities for local small businesses to locally manufacture and provide support to the OpenFletcher microscope in ways that are relevant and useful for local researchers. So this comes to a point that Alex was mentioning earlier, which is a common misconception that open source technologies have to be non-commercial or only done for free. But the answer is no, because if you look at those four fundamental freedoms that I talk about as foundational to the definition of open source software and hardware, you will see that it doesn't say anything about, whether you can sell it or make money from it or not, as long as you ensure these freedoms for users of those technologies. And if you look at examples of projects that are very well known in WILDLABS, for example, there's the FieldKit project that produces completely open source environmental sensors. Both the hardware and the software stack are completely open source, but they also sell complete kits to people as a revenue stream for their business, right? And this has become a very successful example. And FieldKit, it's a pretty big deal right now. There's also the Aribada initiative, which provides paid consulting services to design and produce customized open source technologies for specific conservation applications. So these are just a couple of examples that show how, making money and open source technologies can actually work together to achieve positive conservation outcomes. So there are a lot of other things I can go into that I'm happy to do so later today or as part of the open source conservation solutions group in WILDLABS. But I'll just end by saying that open source technologies really enable inclusive and equitable solutions to so many of the urgent crises that we face today, whether that's climate change or species extinction. And at the end of the day, we simply don't have the time to be alchemists. We cannot afford to not open source the work that we do. And with that, I just want to thank Alex for inviting me here today. And thank you for your time. In the spirit of what I just talked about, I've published the editable slides for this talk to Zenodo that you can remix. And I'm happy to answer your questions and continue the conversation. So thank you so much for having me today.
Thank you so much, Pen. And thank you for publishing that for everybody to see it. If people have questions for Pen, nice. You probably beat me to what some of my questions were, but I'm still gonna ask them anyway. Like if somebody doesn't know anything about open source technology and wants to like transition to using more of those types of tools and hardware, software, or even just like get familiar with the space, like what is your like step one like direction to those people?
Are you talking about people who want to use it or actually make it,
Yes,
Alex?
both.
Both. Both. Yeah. So when it comes to using those technologies, obviously one place to start it would be the WILD Labs inventory because a lot of the projects in there at least are labeled as open source. Now, like I mentioned, there is an industry standard for generally what it means, so you can check it against those definitions. And when it comes to making open source tools, again, the general principle is that when you've created a piece of software or a piece of hardware, when you share it, you publish the underlying source code and the schematics and the design files using open source licenses. There's a few steps to that I'm happy to go into, but the point is that you share what you've created with other people in a reproducible way, and share them with explicit, permissions for other people to make use of what you're sharing, if that makes sense.
Yeah. And I know there are some discussions and maybe like frustrations in the open source community of like open source washing, like or like companies that say that things are open source but they actually aren't. Is there any like guidance you can give on making sure and helping people like navigate those types of situations of verifying what is really open and what isn't?
Yes, so it is called open washing. For instance, there are sometimes people who buy a software package for what they want to do, and then they realize that it comes with a lot of restrictions. For example, it says, "Oh, you're not allowed to make a derivative work that creates a competing product," for example. But if you look at those four fundamental freedoms I mentioned, it violates the fact that you shouldn't be restricted in what you do with a piece of open source technology. So I think this boils down to the fact that it is important for us to develop this common language of exactly what open source means. Because once we have a specific meaning in this shared language, then we can apply that to look at whether a piece of technology is open source. And if it isn't, then we can say why it doesn't meet that definition, if that makes sense.
Yes. I remember, I think probably about a year ago, you made a post on Wild Labs about like sort of using like veganism as a metaphor for open source solutions and that it has meaning and the meaning is important and that specific things make something not vegan in the same way that it does for open source solutions. And I think actually the Wild Labs website is maybe down right now. So if you're trying to click on any of those
Ah,
links that we sent and it's not working, you're not alone. We're working on that in the back end. But hopefully the website will get back up soon, and I'd love to share that post in the chat because it did a lot of good for me for understanding sort of the importance of it of having these clear-cut definitions.
mhm. Yeah, that's a good point. Thank you for reminding me of that. So I'm happy to share that again as well. Once the website is working.
Bummer, we sent all these links about about the conference and the website crashed, which maybe means that we're getting so much interest that it just couldn't handle it. Anybody else have any questions for Penn? We have a little bit of time left, so we could probably do some live questions answering now, or for any of the other speakers, perhaps. All right, I won't hold you all hostage. Well then with that, I don't think we've ever ended early before. So this might be a record. Maybe I did too good of a job of keeping us on track. Well, so again, thank you to all of our speakers for these lovely presentations. I'm going to end the recording now, but everybody is invited to stick around for what we call after hours, which is an unrecorded place to hang out, to talk, where you can have a more casual conversation about some of the topics that we heard about today or really anything else. So thank you all so much for coming, and we will see you at the next and last Variety Hour of 2025, which will be on November 26th. Thank you so much for coming.